Hey, welcome to my channel. My name is Jack Jusko. I am a computer science student at the University of Michigan who's taking a gap year due to coronavirus. This video is number 1 in the video series Programming Vlogs, where I document what web development or other development I'm doing, what needs to be done, and give you a step-by-step process of what I'm thinking as I work through what issues I need to solve or what features I need to create. Today is featuring a piece of software that I'm working on that allows developers to rapidly prototype and create applications, and I hope you enjoy. Alright, now that I've got my drawing environment open, I'm going to explain what it is I'm working on, why I think it's useful, and yeah. So I'm trying to optimize the process of creating prototypes for web applications. So when you create a web application, and you want to prototype something, you can concisely put in a link and send to people, and they can see it working on the front, they can see data being saved, they can see data coming back, etc. There are a couple things you need. First thing you need to do is you need to pick, you need to pick a front end framework, because you need whatever is going to run in your browser. Now this can be plain HTML, CSS. Oftentimes HTML, CSS for older applications has been paid with jQuery. This can be a different, solely HTML-based framework like AngularJS. And I'm talking the legacy AngularJS here. For those of you familiar, this is a framework created, I believe, by Google, though I'm not confident on that, that can run straight in HTML and JavaScript. Or you can pick something that has to be not compiled, but it has to be built to JavaScript based on how it's created, as in Vue, React, or the new Angular, which is 2+. So that's the first thing you have to do. And then after picking that, you have to, if you're picking one of these, for these all you have to do is copy your template files, which you have to create template files and find them. First you just have to copy them to whatever file server you're using, and I'll get to that in a second. For this you have to find your build tools. You need to install them on your development machine, and then you're good to go. So that's in terms of front-end framework. So secondly, you need a back-end, not exactly a framework, but a system, a way for setting up endpoints. Applications, especially web applications, commonly use WebSockets or a REST API at this point. REST API is infinitely more common. The vast majority, I'd say, of web applications are programmed using get, patch, post, and delete endpoints that are running on some piece of back-end software that's hosting an HTTP server that's allowing these endpoints to communicate. And this is usually your data layer. So you have to pick one of these. It could be Node, very common one. It could be, excuse the bad drawing there. It could be ASP.NET, another super common. Ruby. Ruby on Rails is very common. This is with Ruby. This is C#. This is Node. This would really be Express.js. Which is what's actually hosting your web API here. There's Django, which is Python. So regardless of which one of these you pick, you need to find your development machine. You need to install this environment. You need to figure out a way to get it running, etc., get everything configured properly, and then you're good to go from there. Third, which isn't necessarily for all applications, but it is for the vast majority of realistic prototypes that you want to create. You need some kind of excuse me. You need some kind of DB or database engine in order to store files, store content, retrieve content, etc. This can usually be run on whatever development machine you're working on. There's generally SQL or no SQL. Say the most popular SQL applications are SQLite, which is an easy to use file system contained SQL engine, or MySQL, which people like because it is free. And then NoSQL, Mongo. If you're not familiar with these, I'll link these in the description. It's definitely one of the most popular, or maybe DynamoDB, which is an Amazon product. So even after you've installed these, if it's necessary with your application, which realistically it probably is necessary, then you have to install as usual. If you're working with any of these three, you need to create a database server, which allows your database to be open and allows write and read requests to be made from it. If you're using SQLite, this is a different story because it is a file system database. It's meant for local applications and it doesn't really need a server to run. It's a kind of a standalone piece of software. Then, finally, you have all this set up. Among you and if you're working with a small team, you need to set up Git or TFS. Git is a most common. It's a versioning system. It's a collaboration system. I'd super invite you to look it up if you're interested. TFS is Microsoft Team Foundation Server. It's another very common versioning and collaboration system. You have to set this up with your project. Say you actually want to show this to people without having to turn it on 24/7 from your computer. You have to create a VPS, which is a virtual private server. It can be used as a virtualized operating system on somebody else's server, which can be used to host applications because you can pick how powerful and how many resources you need. Take your application, put it on there, WA, web app, deploy it. If you want your application to look nice, you have to get an SSL certificate, which is for HTTPS. If you want this prototype to look nice, you have to get this registered with a domain, which you have to either buy or use a free alternative, such as FreeDNS or FreeNAM. Neither one are fantastic options, but that's not the point of this video. Sync that up with your web app, maybe with your VPS, save it somewhere, and then finally, you are good to go as long as you remember to redeploy your application whenever a new pressing change is made. Now, this is what I'm trying to solve, and I'm closing out of my drawing environment for a while here. Right, that's not online. So I'm opening up Winscp here, which is what I'm commonly used for working on applications like this, because it gives me SCP file transfer. AWS Lightsail is what I'm using at the moment as my virtual server. Open up, connect to this. You can see you're in the directory for my application, which is called protoblock. I'm running lots of different things on this VPS, which is all hosted by this proxy. You can see the code for that there. Not exciting. Anyway, so I'm going to open up an SSH session and change directory into my working directory for protoblock, which is this collaboration system I'm working on at the moment. Now, I'm going to open up the backend. This is a Node.js Express.js, one of the things I just documented. Node.js Express.js backend. You can see some of the code for this here. Anyway, come back here, go to Protoblock. This website has pretty much nothing on it. I know. I haven't gotten to that part yet. Alright, I gotta bleep that out of my thing, because my password was just exposed for a second. Log into this platform. So, I'm gonna move myself over here. Here's what I'm currently working on. This is meant to be a platform where you can easily just pick a front-end framework, as I just went over, and what you need. Pick a back-end framework, pick a database engine, whichever database engine you need. I've included 3 of the most prominent free ones. I can't put DynamoDB in here because it's an Amazon product. So say I want my application to be called Jack Demo. I want to use AngularJS, the 1.7.x edition. These gray ones are ones I haven't implemented yet. I want to use Node.js as my backend, and I want to use SQLite as my database engine. And I'm going to open up Network Inspect here for a second. And I'm going to hit Create. So now you can see creating new block there. On the screen, you can see that the create block request, which is a post request to my endpoint, went through. You can see token for authentication system. You can see the data that was sent along with the payload. And you can see the resulting IP. So what's happening in this create block call is this is spinning up a virtual server using Amazon Web Services. It is automatically provisioning it, and it's opening up what's called an AMI, which is basically like a disk image, which has some software, some endpoints that automatically start up pre-installed. It returns this IP, which can be used to find the server, which my stuff can use to connect to the server. And now it is sending this ping request, which is currently on pending. Now, this request is still currently on pending because the server has not initialized itself yet, the one that was created in create block. This link, this protoblock.ftp.sh, which has now gone through correctly, is what's called an HTTP proxy. Here I'm solving the issue of having to create an SSL certificate for your new project in order to use it. Any traffic coming to one of these servers can go through a domain that I already own, at least for internal communications. The proxy code that I have set up reads this route of the request that's coming through. It takes this part and figures out what IP address it's supposed to be connecting to based on what block or node name I provided. It goes and makes that request to the block. It returns it completely over HTTPS for the end user. Ping, successful, it's online. And initialize, which does some basic file copying procedures, etc., just to initialize the system. So now that's not important anymore. I can hit Open Editor. Okay, good, just took a second. Your app is currently live at front.protoblock.com/jackdemo, which is here. This is another HTTP proxy. This is a different link. It's a more professional link. It is proxying to a different server on this new virtual private server, a different HTTP server that's been created. And yeah, and front.protoblock.com is a bit of a cleaner URL for people to be able to use. Now, what I have in here, it's not very exciting. A table that's using pure CSS, if anybody's ever heard of it. List of files. And what this is, currently has a continued deploy system in it. So I'll show you what this is. This link is currently running on a new virtual private server that's been created on Amazon. And I can actually show you that instance running if I sign into the console here. So here's the new server that's running. You can see that IP address is the same one that showed up previously. If I want to do a connection to it, I can. Hit yes. I can see all of the internal stuff that I've created in this disk image. And what I've put in this disk image is actually continuous deployment for this front-end application. And what this means is anytime you make an update here, it'll be redeployed into this file server. And this is actually a live code editor for what is in this front. And I'll show you how that's set up. This is the default demonstration application I made. But say I want to go and change this. Here is the home template in my new Angular JS app. So I can go into templates, I can go into home, I can open up home, put hello world. And now you can see that I can click back and refresh this page, and hello world has updated live. I can edit this again, I can show you the network request, where autosave goes through again, 200 OK. And then my live demonstration has updated a second time. That's all I've got for today. Thank you for watching. If you found this interesting, let me know. Like, subscribe, comment down below what you thought. If you didn't think this content was interesting, but you have something else you'd like me to talk about or you'd like to hear about, feel free to leave a comment below, and if I can, I'll get to it. Signing off.